In this video, we're going to write the implementation for the equals method for our student class. Remember that the equals method that's contained in the object class just compares the memory addresses, but we'd prefer to compare the contents of the two objects to determine if they're equal. We're going to write our equals method so it just compares first names and last names, and it'll return true if those two values match for the two objects, and will return false in all the other cases. So let's look at the code that we're required to write. This one's a little bit more complicated than the string class. Some of the statements in here look kind of confusing, so we're going to walk through it kind of one line at a time. So the first thing that we need to include in our student type, I'm going to put it right here under the string method, is the @override sign. That's telling it that we're overriding a method that's part of the Java class. And we're overriding the public boolean equals method that takes an object. And in my example, I'm going to call my object O. And so that's kind of confusing in and of itself. So we're saying this equals method, it returns a Boolean. So that part makes sense, that we'd want to return either true, they're equal, or false, they're not equal. But the fact that we're using this object over here, what does that mean? What it means is that we're going to accept an object of any data type, because remember that the object class that's in the API is the superclass of all superclasses. It's the class that every class inherits from. And so any class that inherits from a class, we're able to substitute it for that data type. So we're putting object up here, but we'll be able to call it using an object of our student class. So then the first piece of code that we want to write in here is something that makes sure that we're calling this particular method and that if we're calling it with the object that is the same actual physical object as the parameter, then we know they're equal. So in other words, if in our main program we were writing something like Boolean result equals student1 dot equals student1. In that case, we want to return true, right? Because these two are the same physical object. And so we don't even have to like waste a lot of time doing a special check in that case. We just want to return the value true. So that's what this first bit of code here means. If this, that's the calling object, equals O, the parameter object, then we're going to return true. So again, in fancy words, that means if this calling object, thing in front of the period, is equal to O, the parameter object, thing that's passed in as an argument, if they're physically the same object, if they're stored in the same memory address, then we want to return true. The other thing we want to check is to make sure that the parameter isn't null, so that they have to have actually put a good data value in there, and that the class of the two objects we're comparing are equal. So in other words, Java will let us call this method with something like student1 dot equals, and then like first name, which is one of the strings that we have in our class. You can see there's no like red squiggly line there or anything. It'll let us call it with that. But we know that if we're comparing a student object and a single string, there's like no possible way those things are equal. So our next bit of code in here where we check to see if O is null, that means if the parameter doesn't exist, or if the class of the calling object, if that's not equal to the class of the parameter object, then we know that those two objects are not the same. If the calling object exists, it has to, that's the part that's before the period. If we call it with like student1 dot equals null or something like that, like there's no way those are equal, so we're just going to return false. Similarly, if we have a case like this where we're calling it with a student and a string or some other kind of data type, there's no way those are equal, so we're going to just return false in that case. Now, if we pass these two initial tests, then we know that we have student type objects and the parameter is not null. So now we're safe to like make some assumptions about how to interpret the data. So the next thing we're going to do in here is typecast the object, the parameter, as a type student, and then store it as a student in our program. So right now the computer thinks of, oh sorry, mine's called student type. This computer thinks of the parameter O as an object, but now we're going to start thinking of it as a student. We're just saying treat my object O as though it's a student type because it is. We wouldn't have gotten to this point in our code if the calling object, the thing in front of the equal sign, and the parameter object weren't of the same data type. And we wouldn't be calling this version of equals if the calling object, the thing in front of equals, wasn't a student. So now we're safe to make comparisons. We can compare the calling object and this new student type or this new student version of the parameter object. So I'm going to say if the first name is not the same, then compare whether the last names are the same. Let's say if the first name of the calling object is not equal to the parameter object's get first name, then I want to return false. So if their first names don't match, then they're not the same. And then otherwise, I want to return whether their last names match. So if equals returns true for those, then I'm going to return true. If equals returns false, then I'm going to return false. Cool. And that's the whole implementation for my equals method on my Java doc up here. This is the object to compare to. This is overriding the equals for the student type. So this is my full method. On your note sheet, it looks a lot longer just because it has lots of comments so that you can understand the context. Again, what we're doing is checking to see if the two objects are exactly the same, they're stored in the same memory location, return true. If one of the objects doesn't exist, or if the objects have different classes, they can't possibly be equal, so return false. If we get to this line, we know that we have two student type objects, so treat the object as though it's a student, and then compare the data fields that we're interested in for our particular data type. We said we were just going to compare first name and last name, so I created the comparison to return true or false based on those. If you are more comfortable writing these comparisons in a different style, that would be totally fine. If you wanted to write like if get first name dot equals student dot get first name and get last name dot equals student dot get last name, return true, else return false, that would be totally fine. It does the same thing. It's just a different style of writing it. So let's recompile our main program to see what happens when we compare student 1 to student 3. Remember, those store the same data types or store the same data values, but they're stored at different memory locations. So you can see they both store the same memory location, and now when we compare them, it says true, they're the same value. And that's because it's using our new updated overridden version of the equals method that we provided in the student class. So you might be wondering, like, why does the default version not work for the toString method and the equals method? Why does it use the memory addresses instead of doing something more useful? And the reason it does that is because the version that's in the object class has to work for every object on the planet, because every object inherits from that original object class in the API. And Java doesn't know how to specify all the different data types and the different data fields and how you might want to compare things. And so the default version that it creates works in a really generic way. The only thing that it can guarantee that every data type has is a memory address. That's why the default version uses those memory addresses rather than the contents of the object. In general, whenever you write a class, you'll be able to use the getClass method that's provided in the Java API without modification. But if you want to use the toString method or the equals method in your class, then you should write those and override the version that are in the object class so that you control how objects are compared and also what information displays for debugging purposes if you call the toString method.